All right, so welcome everyone to our sixth workshop. Today we're going to be going over some testing and some advanced backend topics, but we're mostly going to be focusing on just how we test in Java in particular. So like I said, we're going to go over testing. That's going to be using two different libraries, JUnit and MOCKITO. So we're going to be going into a little bit of the details with that and looking at some examples of code. And then we're also going to talk about some different HTTP types. We talked about GET requests last week. Today, we're going to talk a little bit about POST requests. And then along with that, we're going to talk about DTOs and how we can work with JSON in Java. So let's talk about testing. So you'll hear a lot in all of your fundamental classes of why you should write tests, but really, as much as it may not be fun to write tests, you really should do it. Just a couple reasons for it. Just of course, kind of like verifying like your standard use cases for your code. Whenever you're looking for bugs, tests really help you eliminate uncertainty that you may get when you're just trying to like manually verify something. It's also really important if you're working with a bunch of different modules that are all working together, or you're working with a big team of people, or even just more than just yourself. It's really important to have tests so that you can have a level of confidence in your code. They can also help you down the line if later you add some changes to your code that introduces new bugs. These tests can help you catch that early on. And you can also use tests to just ensure that your code works at like a production level of workload. So there's a lot of different kinds of tests that you can do. We're mostly going to be talking about unit tests today, but I just want to bring these all up so you guys kind of know that testing is not just writing like unit tests for your methods. But like I said, unit tests, they're kind of like the most basic form of test, the smallest functionality that you're ever going to want to write a test for. A little bit bigger than that is an integration test. So this is working with multiple modules of code, different like systems in your program. Integration tests make sure that they can work together correctly. We also have end-to-end tests. So these more try to follow a typical user workflow using your entire application. So if you were working on a website, for example, an end-to-end test would be some kind of test of going through, and maybe it was like a e-commerce, just like ordering a product and adding it to your cart. And that would be an end-to-end test. Acceptance tests are a little bit more formalized if you're working at like a co-op or any large company that has very specific requirements for your program. Acceptance tests will be measuring against like a standard set of requirements, making sure that your program passes all of those. We also have performance tests. So performance tests are more about if your program works, make sure it also works when it has like a lot of different requests coming in, a lot of users using it. And those typically test just like the speed, reliability, stability, and availability of your application. And then finally, we also have smoke tests. And smoke tests are just a really basic form of tests that are meant to kind of, they're called smoke tests because if there are a fire, smoke tests should be the first ones that catch that. You'll often see in websites, for example, a smoke test could just be looking at a page and making sure that a couple elements that you expect show up. Really basic, really simple, just catching any huge bugs as soon as you can. Like we said, though, we're mostly going to focus on unit tests today, and that's going to be mostly what you do throughout all your Fundies courses and OOD. You're almost exclusively going to be writing unit tests. So in Java, and in Maven specifically, which is the program that, or the framework that we're using in the Jumpstart backend, the typical convention is that all your test class should mirror the class that you're trying to test. So you can see, let me see if I can, 1 second. So if we have our main class up here, we can see the package structure, the folders that it's under, is going to say service/source, then main Java, then a couple different subdirectories into that. And then the test one is going to be in the exact same place, but instead of source, we have test here. And then, of course, whatever your test is called. And whenever you're thinking like, what unit test should I make? It's basically any public method that does any non-trivial logic. And you can have some kind of disagreements about like what is classified as non-trivial, but really any kind of like if statements, for loops, especially just anything more complex than really just like returning a value is probably worth writing unit tests for. You can never really over test for these methods. Having more is usually better. And you should just be trying to capture both like the basic use case, something that you would kind of expect, and then also thinking about any edge use cases, just kind of any weird inputs, anything that could trigger, anything that might trigger some weird functionality. You want to be sure that you're testing that and know exactly what's happening there. So JUnit is the main library that we're going to be using for our unit tests, and we'll see examples of these in a bit. But really, JUnit I kind of think of as two main aspects. They're annotations, which if you haven't seen annotations in Java before, they just have this little @ symbol, and they go right above a method. And they're assertions that JUnit gives you. So the annotations, when you write test methods, you can use the annotations to declare them as doing certain functionality. The most basic one is @test, that you just put above a method to specify that this method is testing some other method. And then in those test methods is when you're going to use these assertions. And assertions all are just assert and then equals or assert null or assert true. And really, we're just checking that value we have is what we expect. So the most basic one you're going to see everywhere is assert equals. It just takes an expected value and an actual value, and it'll just tell you if they are the same. Really basic, and if they're not the same, then the test is going to fail. So let's look at some examples of this. And before we kind of like talk about tests, we have to know what are we testing. So let's say we have this hypothetical method called add special. An add special is going to take in two arguments, A and B. It's going to check if A or B is less than 0. And if either of them are less than 0, we're going to throw a new illegal argument exception. Assuming they're not less than 0 and they're positive, we're then going to add A and B. And then we're going to say if the answer, if A plus B is greater than 20, then we're going to multiply 1 and make it negative. So it's a little bit of a contrived method, but if this was the method that we were given and our task is to then write unit tests for it, what are some different inputs that we would want to test? You guys can answer in the chat. I think I should be able to see that. I'll give you guys a second. Yep, we definitely want to be testing negative inputs for A and B because we have this if statement here. What are some other things? Checking for either or both values at 0. Also inputs where A and B is greater than 20. Anything else? There's a lot of things that we can test. Inputs greater than 1 and less than 20. Exactly. So that's kind of, we've gotten like the big groups here, which are the negative numbers, the ones from 0 to 20, and the ones that will add up to be greater than 20. Also, along with that, like we said, we want to be testing edge cases. So maybe we want one where A and B add exactly to 20, or maybe like A and B are both ones so that they're close to the same value. Let me see if I can, there we go. And just some other things like that. So let's look at what these tests might look like. So excuse the big code block, but so this is some JUnit tests. We can see we're using the @test annotation above a public void method in our test class. Important thing to note with these methods, the convention is usually just have test somewhere in the name and then just the method that you're testing and just kind of like what the use case is. So here we have test add special with 0 inputs. So we're giving A and B as 0 and 0. We can do some small ones like 3 and 4 that don't add up to 20, ones that add up over 20, ones that add exactly to 20, and also this exception case, which is a little bit different. There's a lot more that we could do, like negative inputs, or I think we said like either or A being only one of A and B being 0 instead of both of them. But this is basically the format of a unit test in JUnit. We're going to call our method, and then we're going to start equals with our expected value, 0, and our actual value. And then down here at the bottom, when we're trying to test that exception case, we're going to be using a try catch block. If you guys have not seen a try catch block, essentially they're used for catching exceptions. You can see in our method when we're throwing this new illegal argument exception, we have to wrap the call in a try catch block, and we're going to say call add special with these negative inputs. If the exception is thrown, we're immediately going to jump to the catch block. If it's not thrown, then we're going to call this fail method that JUnit gives us, just with a message of like why this test should fail. Because if the exception is not thrown, it's not what we expect, then we want to say the test is a failure. If we do catch the exception, we don't have to do this, but I like doing it, where we actually then call an assert equals on the message. And if we do all of that, then we can be pretty sure that our exception was thrown. We got exactly the exception that we were expecting. So let's talk a little bit about MOCKITO. And this also gets into a little bit of the theory behind unit tests and like what makes a good unit test. So essentially, a unit test really should just be that. It should be a unit. It should only test the single function, and ideally it shouldn't test any other behavior outside of that. But a lot of the times, the methods that we're going to be testing are calling different methods in other classes. And while we could just kind of like ignore that and just still test our method, then we get into a lot of kind of weak cases where we have to test these other methods that we're not really that interested in like how they're working. And we have to worry about all sorts of different other objects with that. So MOCKITO is a library that lets us kind of mock these objects. So instead of calling real code in our methods, instead we can call mock objects. They'll just return results for us and basically do no special functionality so that we can be sure that we're only testing a single method with it. And really, like we say here, it allows us to isolate the function of a single method. Whenever you're writing unit tests, don't try to test more than the method. It's really easy to kind of get into a mindset of trying to test all the functionality, but you're really just doing your disservice by trying to go beyond the scope of what a unit test really should be. So let's look a little bit at the syntax of that, and then we'll look at an example. So essentially the workflow for MOCKITO is we're first going to create a mock object of a class. Then whatever method that we're trying to mock, we're going to specify some specific value that we want to be returned. And then once we call the method that uses our mock, then we can also verify that the method we're interested in was actually called. So we can see up here, say we have this sum class that we are using in our method that we're trying to test. We can call the MOCKITO.mock method. We pass the class value, which is just the name of the class dot class, into the method, and it'll return us an instance of the sum class object. Then we're also going to use these MOCKITO methods. We're going to say do return. This is the value that we want to be returned whenever we call this method. All right. So the first thing I will address, why can't we use regular classes? So a lot of time we can just use a regular object. If some class had some easy constructor that we could just create and then throw into our method, that's totally fine. The reasons we may want to use a mock instead are kind of twofold. One is a lot of the times these classes are not actually going to be very easy to get a copy of, especially when we're working with these large libraries like Vertex that do a lot of our API stuff. A lot of the classes that they use are actually don't let you just create new values of them really easily. And in that case, we wouldn't want to go through the whole process of trying to get an instance of a real one of these. So we just want to mock it. And then the other benefit to mocks is, like we were saying earlier, if we use a mock instance, then we're sure that we're only testing the code that we want to test. Because if we're using a real instance, then those are real functions that are being called that can have their own complex logic that we may just not care about, not want to deal with for this specific unit test. So I hope that answers your question. And if you guys have any more questions, feel free to leave them in the chat. And then really quickly, we'll just look at this do return statement. All we're saying is do return whatever value you want to be returned when, then we're going to pass our mock object, and then we're going to call the method that we are trying to mock. So when some mock method, where some mock method is the method we're trying to mock. I hope the names. Then we're actually going to call the method that we're trying to unit test. Like we said, we're going to pass in our instance. And then after the method has been called, we can do our own assert statements later if we return some value. We can also call this MOCKITO's verify method, which allows us to verify that some mocked method was called exactly one time. And this can be really helpful if you're working with like void methods that you want to make sure are actually being called in like different if statements. And it's just kind of generally a good little sanity check to do. So let's look at an example. All right, so on the left, we have our source code, the method that we're trying to call. It's called GameResult. GameResult is going to take in a random object. Random is a class that is predefined for us. And random gives us a random number from 0 to whatever input is. So from 0 to 10. And we're going to say if random is greater than 5, we're going to return the string winner. Otherwise, we're going to return the string loser. So this is another great instance of a case where we could use a real random object, but then it's not really a unit test, because if we try to give a real random object, it's going to give us a real random value. And we don't know what part of the if statement we're going in at any given time that we run the test. So we definitely want to use MOCKITO here for the random object. And the way we do that, in our test class, we're first going to create an instance of the main class. We need to create this if we want to actually call game result. And we're also going to set this random object. We're not going to give it a value here. And instead, we're only going to give it a value in this setup method. We're using the JUNIT before each annotation, which is going to tell us to run this method before every test is run. Of course, we only have one test here, so it's not super useful to do this. But if down the line we had multiple tests, it would be helpful because it would just give us this predefined mock that we can use. So then in our actual test method that we're defining with our @test annotation, we're going to say do return 456 when this dot mock random, our mocked random class, calls dot next int with any integer. So there are two interesting things going on in this line. The first one is this any int method. So whenever we're trying to mock methods that take in arguments, we have to use one of these kind of specifiers. And MOCKITO will define all of these for us. So usually you can kind of get away with the any int, or if next int, for example, took like a string, you'd use any string, any object. They're all easily Googleable, and all online. So we just use the MOCKITO thing. The other interesting thing going on this line is that we're specifying multiple values in this do return method. And that'll say each time that we call it, we're going to go to the next input. So the first time that we call next int with our random object, we're going to return 4. The next time we call it, we're going to return 5. Time after that, we're going to return 6. And I didn't mention it last slide, but after we return 6, and if we call, for example, any other method on mock random, we're just going to be returned a null value. So by default, MOCKITO, whenever mocked methods are called, is just going to return null, which we normally shouldn't do. As we talked about last week, we don't really want to work with null normally. So once we set up our specifications here, we're going to call game result 3 times in our test, and we're going to assert that the result 4, of course, is less than 5, so return loser. 5 is not greater than 5, so we also return loser, and 6, of course, is greater than 5, so we return winner. Then down here at the bottom, we're just going to add in a little verify check. We're going to verify that our mocked random object was called 3 times. It was called next int with any integer. There are a couple more advanced things that we can do here. If, for example, we want to know what the arguments to the method were, we could do that with things called argument captors. We're not going to go super into it right now, just because it's a little complicated, and you can usually get by without them. And there's also a couple examples of those in the starter code for this week. So what if we have this method now that we are trying to test? So it's pretty much the same as the last method, but instead of taking in a random object, now we're going to be calling this number generator .getInt. And number generator is a static method. So what are our options here? Essentially, we can't pass in a mock anymore because it's just calling number generator specifically. But we don't really want to just test it without this, because again, if that's introducing randomness into our test, then we can have an issue where our test will fail randomly based on whatever number generator is giving us. So does anyone have Any thoughts on what our approach should be?
This
Give it a
one's a
second.
bit of a tricky one. Do you have any hints for anyone?
I do have a couple hints. So I won't make you guys wait too long, but essentially MOCKITO does not have a way of mocking a static method. So as it is right now, there's really nothing MOCKITO can do for us. There are different libraries that allow you to mock static methods, but just because of the way Java works, it gets really finicky, and you can run into a lot of really weird bugs if you start trying to work with those libraries. So generally, you should try to avoid that. Instead, what we're going to have to do is we're going to have to rewrite main. We're going to have to change our source code so that's easier to test. And let's just jump into that and kind of break down what we look like now. And kind of the biggest takeaway from this that I want you guys to realize is that it's okay for us to modify our source code to make it easier to test. I feel like, especially when I was on like my first co-op and I was writing unit tests, I kind of had this idea in my head that you should write the source code, and then when you're writing tests, like you just want it to be uninvolved and like not touch the source code at all, and just has to work with whatever's there. Where really code being easy to test is a great thing for it. And it's something that you should try to design for and should try to make possible. And this is one of those patterns. And it's a little bit of an interesting idea to wrap your head around, but it's really powerful and lets us get around this static method mocking problem. So what are we doing here? So the first thing we'll notice is down here, we've defined an inner class called externs. In Java, you can create classes within classes. That's what we're doing here, where externs is just something that is specific to the main class. And the class externs is just going to have a couple methods that specifically they copy the static methods that we were calling before. So in externs, one method called getGeneratorInt, we're just calling that static method here, numberGenerator.getInt. We can see our main class then has an instance of externs that it keeps. And then whenever we need to call a static method, we don't call it directly. Instead, we call the externs.getGeneratorInt. To support this, we're going to have our main method, our primary constructor over here that the rest of our source code is going to use. It's just going to create a new instance of externs and just pass it in. And then we have a package private constructor that takes in an instance of externs. So I hope you guys can kind of see where this is leading. Essentially, this will allow us to, instead of mocking number generator, we're just going to mock the externs class that we pass into main for when we do tests. So I'm gonna let this soak in for a second. Try to make sure that you kind of understand what's happening here. We're moving our static methods into a inner class, and then just wrapping those around non-static methods that we can then mock. So once we have that, let's look at our test code. So this is pretty similar to what we had before. A couple differences. In here, in our second line, now we have a main.externs. That's just how you refer to an inner class that we have outside the test. And we're also not actually initializing main outside. Instead, we're initializing main in our before each setup code, where we're first going to mock the externs class. Now we're going to pass it in to the mains constructor, and we're using that package private constructor. And if you guys haven't really gotten to the like privacy levels of Java yet, that's totally fine. Essentially, when I'm saying package private, I mean that instead of having public here for main, we just have no specifier. And that'll mean anything, any class that is in the same file structure as wherever our main class is can access this constructor. And conveniently, because of where you write tests, that means our test method can call it. Then once we pass in this mock, we can use it the same way that we're using before. We can just specify some return values for the get generator int, call our game result method a couple times, and still verify it down at the end. So any questions about what we're doing here? Because I know it can be like a little bit of a tricky thing to understand at first. No questions? You guys feel kind of comfortable with this? All right, that's good then. The other thing I just want to quickly point out is when I was first learning this pattern, it seemed really weird to me that you would have this constructor here. I was thinking like, oh, like what if some like source code calls it that's not supposed to use this and does something weird? And really that comes back to one of the principles of writing a code is you have to trust that your source code is doing things that make sense. And like you would definitely want to add a comment up here instead of just saying notice this is packed private, or just saying like this constructor is only used for testing, like don't call it normally. And essentially what I'm trying to say is that it's okay to have, you can't completely idiot proof your code, essentially. At some points you have to make compromises, and having this constructor that could potentially be called incorrectly and create problems down the line, the risk of that is lower than the benefit that you're getting out of being able to like test these static methods. So it's okay to make these compromises sometimes. All right, so now we're just going to talk a little bit about, we're going to switch gears a little bit and talk about some quick advanced backend concepts, and mainly post requests and like how we can work with JSON in our backend. So last week, like I said, we looked at GET requests. And I know we mentioned it before, but basically all these HTTP requests are going to include a method, a URL that we are calling, and it's going to return some response that has like a status code and some JSON data. So when we do the GET request, we just call GET to some URL, and then we're returned a big body of JSON. But instead of just getting data, we can also do operations with our data. We can create data with post requests. We can update data with put requests. We can also delete data with delete requests. There are a bunch of other types of HTTP requests, but these four, get, post, put, and delete, are really the four most important ones. And like 90% of the time, you're going to be working with just these. And another large percentage of time, you're really just going to be working with get and post, of just kind of getting data and creating data. And so the thing that makes post different than get is that we're still returned a body of JSON, but in our post request, we also include our own JSON with the request. So this is a little screenshot of Postman, where we see The things we're specifying here are the method of post, our URL. In this case, we are calling localhost because we have our local API running, and then just a body of JSON data that we're giving to the server of this is typically a object that we want to create. So we're calling a post request and we're specifying all the different fields that we need. So this is great. But now that we're working with more JSON we have in our post request, we have to actually have a way of working with this neatly in Java. When we're on the front end and we're working in JavaScript, things are a lot easier for us because, as we mentioned before, JSON and JavaScript objects are pretty much the same thing. And it's really easy to just like translate them together. And JavaScript has all these like inbuilt methods for working with it. In Java, everything's a class. And because of that, we have to create these DTO classes that match the JSON that we're expecting. So we see an example of that, where if this is our JSON that we're expecting in our API, really simple, we're just taking a name field that's a string and an ID field that's an integer. Then we want to create a class that mirrors this structure that we can use to represent a piece of JSON. We call these DTOs. That stands for data transfer object. It's just another acronym there to confuse you. But essentially, it just means these classes are meant to be very simple. They just hold data, they can return it, and they can set their values. So if we have a name and ID, what we're going to do then is we're going to specify two fields, one called name, one called ID, and their types are going to be string and integer, basically just mirroring what we have here. We'll talk about what this constructor is used for in a minute, but outside of that, it's just a very basic object. It has our constructor that just takes all its fields. For every field that we have, we're going to have both a set method, so we're going to say set name, that takes in a new name and just updates that value, and also a getter of a get name, which just returns what the value is. I didn't show the equivalent methods for ID here, but you would also have a set ID method and a get ID method. And then one last thing that is nice to have in your DTOs, it's not required, but whenever we're working with JSON, it's good to have these validate methods that can just check that the data was set the right way. So it's good to just kind of like do null checks, make sure that our name or ID is not null. If we had other requirements, like maybe we're saying IDs can't be negative, we could also throw that in here, just checking that the ID is greater than 0. And the reason for this is if we're making an API and we're taking in data from a user, you never want to trust the user to like do things correctly. So you should always have some kind of like some kind of safeguard if you were given just a bunch of garbage data in your class is invalid for that. So having these validate methods, you'll see them in the code. They're just a useful check there. So now we have to talk about the private constructor while you have it. And essentially, it's for this idea of marshalling and unmarshalling. And marshalling and unmarshalling are just fancy names for basically going from JSON to a Java class or vice versa. Marshalling is going from a Java class to JSON, and unmarshalling is just going from JSON to a Java class. And whenever we're trying to do this conversion, we're going to be using a library for it. Vertex has this built into it. Vertex is like our front end library that we talked about a little bit. But it's also called Jackson if you need to use it for a different class. I know I use this in software development, so you may have to, at some point, it may be useful for you to know. And like we said before, whenever we're going from JSON to Java, we should always verify that our class fields are valid. So what does that look like in our code? So here, we're going to create a DTO instance. We're just going to call this simple constructor. Our name is me, our ID is 1. And then if we want to get the actual JSON string from that, we're going to call this JSON object.mapFrom method, which is a static method. We're going to pass in our DTO, and then we're going to call .encode. And that'll return us a string. It's actually going to be pretty much the exact same as this JSON input that just has these different fields that we can use with their values. And this is what we're actually going to be returning to users when we're creating a real API. Then vice versa, when we have our string already and we want to get an instance of the sample DTO object, what we're going to do, we're going to call new JSON object. Oops, a little bit of a typo here, but this should be JSON input. So we pass the string into the JSON object, and then we're going to call the map2 and then pass in the class object of sample DTO. It's going to map to sample DTO, and that'll give us a sample DTO instance. And then, of course, down the line, if we wanted to verify things, we could. So that's really all we wanted to cover here. Like we said, I think it's going to be very valuable for you guys to actually check out the code. We have it very well commented and a lot of really useful information in there, just kind of getting different examples of this. And actually, if we have some time, we can look at a bit of that code. But before we get into that, since I know we had Halloween last night and want to make sure that people can get out of here if you don't want to stick around, but I'll just mention this Thursday, we have a design workshop with Rain, who is our head of design, which if you're all interested in kind of like the front end design aspects of things, that's going to be super useful. And next week, we're going to get into some more front end techniques. We're going to switch gears and get away from JavaScript. So like I said, we can look at a bit of code if you guys want to stick around in a second. But before that, if anyone does have to leave, I would love a little bit of feedback from you guys. If you want to use the QR code or this bit.ly link up here, I'll give us a couple minutes. Make sure I can actually see the screen. And Connor or Sadaf, if you guys could just post that bit.ly link in the chat so people can see that, that would be fantastic.
Sure, I'll find it real quick.
Thank you, Sadaf. Let me stop my screen share. All right. If you guys are sticking around, I'm going to assume that we want to look at some of the code you're going to see.
I want to see.
All right. Let's do it. You guys see my IntelliJ?
Yep, looks good.
All right. So this will be fun. So let's look at the package structure we're in. We're still working in API. This is where we're doing all of our routing, all of our Vertex stuff. If we're working with JSON, this is where it's going to happen. And right now, we're down in the REST object in the posts router. So if you guys remember from before, this is where we're going to register all the different routes we want to add to our API. We have a lot more now. We're doing a lot more interesting things with our different posts. Before we were just getting things. And we're going to look at one of the post routes, which is a little confusing because the HTTP method is named post, but we're also creating posts. So we have this weird register posts. I think we can go down here. So like we see now, our Vertex router object, we're calling .post instead of .get as before, and we're specifying our path as just the slash. Then we set up a handler for it called handle post route, which is conveniently right down here. So we have a little helper method to kind of help us out with things called get JSON body as class, which is essentially, it's in request utils. It does a couple like fancy things just to do a little verification, make sure that we get the right object. But we're calling this get body as JSON method from the routing context that Vertex gives us, that under the hood is going to call that Jackson library. We wrap it around a try catch block because this can throw exceptions. So we want to make sure that we don't just throw that by itself. And if we get it, we're wrapping in this optional nullable and we're just returning our value. So essentially we get this create post request object, and the create post request, we define that down in DTO. So DTO is where we're going to define all of our classes that act as our data transfer objects. They should match exactly like what are the JSON that we're expecting in our API. So if you look at the DTO, we have both requests and response packages. So we can look at the requests, see the create post request class is right there. We can open up, see what we have inside. We have our title, our author, and our body. We have getters. We don't actually need setters in this case, but we do have our validate method. The only reason we don't need setters is because we have this little private class. I didn't mention it during the presentation, but essentially it's really weird, but because of the way Java works, where it can be weird sometimes, this private constructor is necessary for it to do the right kind of mapping from JSON into the class. We make it private, which means only methods in this class can call it. Like you see, we're not using it anywhere. And just because of the fancy like Java tricks that the library is using under the hood, it can work with this even though it's private. So, oops, need this meeting controls to go down. So we create instance of our create post request. Of course, then we call validate. If the request is broken or the object is not exactly how we expect it, we're going to immediately return 400 level status code. Do you guys remember what 400 means? No. Sadaf, do you remember what 400 means?
Error something.
Pretty much. 400 is the bad request status code. We're saying you didn't give us valid JSON, so we can't work with this. Try again. If our validate method is true, so we have this little not symbol here. So if validate returns true, this would be false, and we would not go in the if statement. So we would not hit this return. Then we're going to call this create post method. And this gets into a little bit of our interface pattern. And I'll mention it really quickly here, just because I want you guys to get a little bit used to it. We're going to go more in depth in this in, was it 2 weeks, Connor? 3 weeks?
I'm not sure. I don't remember exactly, but I think so, yeah.
2 weeks, but give you a quick peek at that. But essentially what we do is we have this processor, and we're going to call create post, which is going to do the actual like creating of our posts, of inserting all the data with our DTO object. After that, we're then going to end. Post, like we said, is creating data. So we're not going to use a 200 where 200 is okay. We're going to use a 201, which is the status code for data successfully created, basically. But the way we're actually doing this creating posts is with a processor instance. If we scroll up, we can see our processor is a field in our class that is of type I post processor. And that's the last package that's down in API, also called API. And I post processor is just an interface for us. And our interface is basically each method in this interface corresponds to one of the routes in our API. So you can see down here, we have a create post method that takes in our DTO object, and whatever class implements this interface is going to know how to create a post. So I won't go any more in depth at this point, but I just wanted to give you guys a peek of this. Like I said, the code's very well commented. So if you guys want to poke around, kind of try to figure out how things work, the classes that are implementing API are down here in service. Like I said, though, we're going to go into that more at a later date. So I hope you guys enjoyed my little impromptu code check. Oh, someone did guess bad request. Sorry, I didn't see that in the chat. Great job. But thanks for sticking around for the little impromptu check. Hope you guys learned a couple things, and Connor will be sending out a care package later today. So thanks everyone for coming. Hope to see you guys next week, and happy Halloween, happy daylight savings time.
Oh, wait, really quickly, don't forget about Thursday. We got our design workshop then with Rain.
Good catch.